Professor Rad here, and in this video we are going to be finding the features of a hyperbola. So here we go, we've got a hyperbola graphed for us. Now, as with the example we did that had an ellipse, sometimes the foci may or may not be explicitly graphed for you, as they are in this case. And also something nice about this particular graph is that we have some clear points graphed on the asymptotes. Again, sometimes they won't be so deliberately marked. So you may need to use your best judgment for that there, but know that those are things you should be looking for. Points on the asymptotes that are kind of in the same space as the vertices. That's what we would want to be looking for, which we have nicely marked out here. But let's start out with the easy to identify things. I always shoot for the center first, or the vertices, whichever one. Like if the center is not marked, then the vertices are usually the easiest to spot out, but the center is graphed here as a point, and it looks to be at -1, 2. So let's write out -1, 2 for our center. And I'm just going to put a reminder here that this is going to be our HK for when we write our equation later on. And then for the vertices, this looks to be, oh, it's the ballerina point. It's 2, 2. And then this other one is -4, 2. So we have -4, 2 and 2, 2. And then lastly, for the special points, let's state the foci. So we have 4, 2 and -6, 2. 6, 2 and 4, 2. Thank you. Okay, so there we go. We've got our points for the important points. Okay, so now we have to figure out the two axes, the transverse axis and the conjugate axis. The transverse axis transverses or crosses through all the important stuff. So all these important points we just figured out live on the transverse axis. It goes through all of them. So this is our horizontal line that cuts through 2. So we have y = 2. The conjugate axis goes through the middle of no man's land. So it goes through the center. And in this case, it's going to be that vertical line where there are no special points other than the center. So vertical is x = -1 in this case. So that's how we figure out our axes. Okay, now I'm going to hold off on the asymptotes for just a moment, and I'm going to figure out A, B, and C, and then that will help me with my asymptotes, and then we'll get to the equation at the end. So A is the distance from the center to the vertex, and C is from the center to a focus. It's the same as for an ellipse. So from the center to a vertex, it looks to be 1, 2, 3 units. I haven't stated it, but I have been doing this. I'm paying careful attention to the scale on the X and Y axis. In this case, each line represents 1 unit, but sometimes the scales may be different on the X and the Y axis. So just be mindful of that when you're doing your counting. And C is the distance from a focus to the center. So 1, 2, 3, 4, 5. Now, to find B, there are 2 ways that we could find the value for B. One is to use the relationship equation, a² + b² is c². The other way, which is the way I'm going to use here, is to use the graph. And here's how that works. So going from the center to the vertex is A, and then going from the vertex to an asymptote is B. So that's why I mentioned these points are going to be important. So they may or may not be distinctly marked, but you need to know to refer to them. So we're going to count up 1, 2, 3, 4. So B is going to be 4. And that makes sense because that's our Pythagorean triple. 3² + 4² is 5². But again, if you wanted to make sure, if your asymptotes weren't easy to tell what point that was, you could use that equation. Maybe we would end up with like, I don't know, the square root of 15, right? So then it wouldn't be 4, but it would be really close to it. All right, so now for the asymptotes. The asymptote formula is going to be y equals k plus or minus x minus h. Okay, so this is the format that you want to remember for your asymptotes. K is, oh, I'm missing the slope, my goodness. It's either going to be a over b or b over a. So I'm just going to put question mark over question mark. How could I dare forget the slope here? It's a slap on my hand. Boo. So anyway, let's throw in k and h since we know those. Hk, so h is -1, so this is going to be plus a 1. And then k is 2. Now, I always forget whether it's a over b or b over a, so I'm just going to use the graph to figure out the slope. So I'm going to go from the center up to here. So my slope is 1, 2, 3, 4 over 1, 2, 3. So it's going to be 4 over 3. So we have y equals 2 plus or minus 4/3 times x plus 1. Now you can leave your equation like that. I'm just going to write this without those parentheses, just to make it a little bit easier to see, to digest a little bit. If you want to write this out as two equations, y equals 2 plus 4/3 x plus 1, y equals 2 minus 4/3 x plus 1, that's also totally fine. In this case, I'm just going to write it as a single line just to save on some space here. If you wanted to know like the more formal way of finding whether it's b over a or a over b, remember that whichever one is associated with y is in the numerator, whichever one is associated with x is in the denominator. So for example, in this case, a is associated with x because that was my run, and so b is associated with my rise. So that's why we have 4 over 3. 4 over 3. So this is b over a. So speaking of using a and b in our formula, let's go ahead and write the equation of this hyperbola. So we're going to have something squared in the top over a squared minus something squared in the top over b squared in the bottom equals 1. So this is our shape for hyperbola equation. It's either going to be x minus h and y minus k, or reverse it, y minus k and then x minus h. A squared always gets associated with the first one, no matter if a or b is bigger. It doesn't matter. It just gets associated with the first one because we're subtracting, so order is going to be important. So to figure out whether we have an x minus h or y minus k, you want to look at that transverse axis. In this case, it is parallel to the x-axis, so that means the x stuff is going to go first. So we're going to have x minus h over the a squared, and then we have y minus k over the b squared. There you go. That's going to be the form for our equation. So if you remember the shape that your equation should have, it helps you to set the groundwork for where things are going to be, and then we can substitute in the values we know. So a is 3, so I'm going to plug 3 in for a. B is 4, so I'm going to plug 4 in for b. And in fact, I'm just going to square those right away. So 3 squared is 9, and 4 squared is 16. If you want to leave it as 3 squared and 4 squared, you can. I'm going to write them out as 9 and 16. And then h and k, as we mentioned before, are going to come from the center. So h was -1 and k was 2. So x minus -1 is going to be x plus 1. And y minus 2 is just going to be that, y minus 2. All right, so there we go. That's our equation for our hyperbola. Nifty. So in the next video, we are going to do the same thing that we've been doing with the other conic sections. We're going to do this process essentially backwards. So we're going to start out with some of the features given to us, and then from there, find the other features, create a graph, and write the equation. So I'm looking forward to seeing you in that video. In the meantime, I hope you have a most wonderful day, and bye for now.